All right, let's move on to security. So after this, I want to talk about the secure access thing that Infrail are doing. But before we get there, I just wanted to give you guys a bit of a security refresher, just to let you know about Wi-Fi and network security. You probably know this already. In terms of Wi-Fi though, I break it down like this. Today, there are only really 3 viable network types that we can have in terms of security. Look, the industry now has available WPA3. So Wi-Fi Protected Access version 3 is available, but the problem that we have with Wi-Fi WPA3 is it's not yet widely supported by all devices. And this means that if we change our networks to only be WPA3, there's things that won't connect. So for now, we have to be backwards compatible. There is a mixed mode that allows WPA2 and 3 to operate simultaneously, but most people for today are probably still tending to do WPA2. So when we break it down, we've got a WPA2 Pre Shared Key, we've got WPA2 Enterprise, and then we've got an open network, which may be like MAC address authentication or something like that used for guests or something. So what we're going to do is go through these in a little bit more detail. So the first up is WPA2 Pre Shared Key. So the first thing that we need to know is this is the easiest thing. I guarantee you if you're using Wi-Fi at home, this is probably what you're using. You have a single pre-shared key, and that key you put on all your devices and everyone can connect. So that key must be a minimum of 8 characters, maximum of 64, depending on your vendor. Some people do 63. So that's normally a static key. However, within Ruckus products, we support this thing called a DPSK, or a dynamic pre-shared key. Other vendors call this other things, right? So Aerohive call theirs PPSK, private pre-shared key. Meraki call theirs MPSK, I think, or IPSK, I get confused. I think Meraki is IPSK, and Aruba is MPSK. Anyway, so the whole point is there's not like a standardized way to do this multiple pre-shared keys for a single network. Pre-shared key was originally designed only to be one key for the network, but then vendors discovered that it's actually quite easy to have multiple keys. So then we start to talk about how we manage these keys. If we have multiple pre-shared keys for a Wi-Fi network, where do we store the key? How do we give the key to the user, and how do we actually make it work? Within the Smart Zone ecosystem, we have 2 different storage methods for the key. So the first one is the internal storage. This is actually where we can store the key in the Smart Zone. So the key is stored in the Smart Zone controller. The other thing we do is we cache the most 1,000 recently used keys on the access point. So if the AP loses connection to the Smart Zone, then we can still continue to authenticate users at a local level with the most 1,000 recently used keys. However, that's only if we're storing the key inside of the Smart Zone. And there are some limitations to this. We should probably go through them. So if we were to store the key inside of the Smart Zone, the limitations are we can have 10,000 keys per zone, which is quite a generous number, but this is a bound key. So if you've used pre-shared key with Zone Director, a dynamic pre-shared key, you will know that the key is tied to the MAC address of the device that's using that key. So something happened recently and it kind of broke that whole thing for us, and that's the MAC address randomization. So a lot of vendors, Apple, we do it on Windows now as well, and Android especially, these operating systems have started to randomize their MAC address for privacy reasons. So we have this piece of software called Spot, which actually allows us to trilaterate your position and detect users as they're walking past by their beacon frames. And so it's it's taking away the privacy of users, right? So everyone fought back and they started randomizing the MAC addresses. So because of that, we can no longer bind the pre-shared key to the MAC address, which kind of sucks. It used to be a really great solution where if one student took the password out of their device and put it in another student's device, it wouldn't work because the MAC address of the 2 devices were different, and it was quite a good solution. But however, today we're in this situation where we now must move to an unbound dynamic pre-shared key. Unbound means that anybody can use that key. It's not locked to a specific device, and we can have multiple users using that key at the same time. So that's the unbound DPSK. We currently have a limit of 500 unbound keys per zone inside of the smart zone. So keep that in mind. So it's okay for a small school, but for a large school, it's not going to be suitable. And so the solution to that is to move to eDPSK, or external DPSK storage. And so we're going to talk about Ruckus Cloudpath in the next PowerPoint, but for now, all you need to know is what happens is the key is not stored on the access point, or it's not stored on the smart zone. The key is stored in a Radius server, which is the Cloudpath service. And every time you log in, that key is then checked against the Radius server. This effectively allows us to have an unlimited number of keys because it's on a Radius server, and it seems to work quite well. And this is what they're doing as part of secure access. And I'll explain that later. But this is the screenshot from the smart zone. This shows us when we generate a new dynamic pre-shared key. In this case, the key would be stored in the smart zone. And we have this thing down the bottom that says group DPSK, yes or no. If it is a group DPSK, this means it's an unbound key. So it's the same as saying unbound. So you can have a maximum of 500 of these group DPSKs. This is also quite good for guest networks. So you could basically have a different password for each of your guest users or groups that come into your facility. The other thing you can do here is you can actually assign a VLAN based on the pre-shared key as well. So if you have a guest come in and you only want to give them internet access, you could just say, here's your key, put them in the guest VLAN. If you've got someone else who's a contractor who needs more access, you could put them in a staff VLAN just by specifying the VLAN ID and giving them a different pre-shared key. So that's the pre-shared key story. Internal or external? Any questions, comments on pre-shared key? Cool. All right. So you can do a VLAN per key. So WPA2 involves this four-way handshake. And one of the disadvantages with the pre-shared key is that it's possible within the four-way handshake for a password hash to be extracted. And so what happens is there's this algorithm that happens to create a thing called the PMK, which is the pairwise master key. And it's possible to capture the PMK as it's transiting, as someone's connecting to the access point. And if you capture that key, you can then take that and put that, and you can run it in an offline dictionary attack. And you can actually guess that person's password. So this means that the pre-shared key password really needs to be good. If you're using a standard dictionary-based word, it's only be a matter of time before someone's able to crack your pre-shared key. But if you're using something that's really long and is not a standard word and is using uppercase, lowercase, and all these things, then it's going to make it harder to crack. And so if you're using pre-shared key, make sure you use a really complicated key if possible, or make sure you use symbols, uppercase, lowercase, letters, numbers, things like that. So pre-shared key is generally acceptable, but is a little bit vulnerable to an offline dictionary attack. So the thing that's not vulnerable to an offline dictionary attack is WPA2 Enterprise. So WPA2 Enterprise is Radius-based authentication. So we're not using a pre-shared key for encryption. We are using a Radius server to authenticate and do encryption as well. So within Radius, we've got a number of different protocols. Within Wi-Fi, we use this thing called EAP, which is the Extensible Authentication Protocol. So everything within Radius uses EAP, but then we dive down a bit deeper, and within inside EAP, we've got different EAP methods. And generally, the only two EAP methods that are widely supported on every device are EAP TLS, which is certificate authentication, and this thing called PEEP EAP MSCHAP v2, which is username password authentication. So these really are the only two widely supported EAP methods. Let me know if you disagree, but that's been my experience so far. What's that?
We use TTLS, works fine for us.
TTLS?
Yep.
So there are some limitations to TTLS though, right?
Got to tell Android to use it, other than that everything else just works.
didn't think you had mutual authentication on TTLS. Like it's not validating the certificate on both sides of the exchange. But anyway, we'll talk about it later. Yeah. So really, these are the two methods that people are using. People generally don't use certificates though because it's too hard, right? To use certificate authentication, like this is the most secure way to do Wi-Fi auth is use certificates because you're not transiting credentials across the air. But the problem is you've got to get the certificate on the user's device before you can authenticate them using the certificate. And that's something that using secure access that Ruckus Cloudpath tries to solve. And we'll talk through that in the next slide deck. So let's go into this in a bit more detail. With ETLS, which is certificate authentication, we've got two-way certificate trust. So what happens is the client device connects to the access point. Now when that happens, the Radius server sends his public certificate to the client. So the client goes, yep, I trust the Radius server's public certificate. And once that trust is verified, then the client will send his certificate back to the Radius server, and then the four-way handshake will take place, and we're all on the network. And so that is the ETLS method with the cert auth. And then we've got EAP, so PEEP MSChat v2, which is okay, but has some issues around trust sometimes. Now, the big thing with this is what we're doing is we're transmitting our username and password. Yes, it's encrypted, but we're still transmitting our username and password to something over the air. So this opens us up to, like, if there's a bad guy, if I sit outside in your car park and I start my access point putting out the same SSID as the school, I will then get people start to try and associate to me. Now, when people start to try and associate with me, the first thing they're going to do is they're going to ask me for my server certificate. If my server certificate is correct and matches what is known, then they will transmit their username and password to me. There's quite a few issues with older Android devices. Older Android devices by default do not require the certificate trust in order to transmit their credentials. So if you've got older Android devices, some of these devices will just go ahead and transmit the username and password without even checking the certificate, which means if you're a bad guy and you turn on an AP, anyone will connect to you and start transmitting their credentials. So that is the problem with the PEEP MSChat v2. But otherwise, if you're someone who has a Windows domain and you have an NPS Radius server or something like that, like honestly, this is the most convenient way to do secure Wi-Fi authentication. Besides from that small Android issue of username passwords being sent everywhere. Yeah. So what do you guys use today? Does anyone use Eat Peep? Anyone? Yeah. So most people use this. Cool. All right. So that's the state of Wi-Fi security. The other thing we haven't really spoken about is the open network. And so, generally speaking, most people have a guest network. And most people's guest networks are not encrypted. And you can tell that because when you look at the Wi-Fi networks, does it have a padlock next to it, yes or no? I can't bring it up now, but basically when you go to the Wi-Fi list, if it's got a padlock, it's using WPA2. If it doesn't have a padlock, all your stuff is unencrypted. So there's no encryption taking place over the air. So a guest network should only be used, an unencrypted network or an open network should only be used for guest traffic. You should never ever be using an open network, which has no encryption, for any kind of like non-internet based task. Because generally speaking, people are like, if it's good enough to go over the internet, it's probably good enough to go over the air unencrypted. So yeah, for guest access only, look, within the Smart Zone, we have this guest pass feature, and this is built-in guest management. It allows you to do terms and conditions. It allows you to create tokens, like one-time tokens, which are valid for certain periods of time, and all that stuff. So yeah, cool. And finally, I almost guarantee you that everyone in this room that works in a school, I reckon I could walk into a school, plug into your wired port, and I'd probably be on your main LAN, and I'd probably be able to access most devices in your network. You guys agree? What do you think? So wired security is something people haven't really done before. Because people presume that if someone's plugging into a switch or an Ethernet outlet in my premise, that they must be in a location where they're trusted, or, oh no, no one's ever going to do that. It's okay, it's safe. We need to start thinking about wired network security. And this is something that they do as part of the Secure Access Program. And basically, it's the concept of effectively doing radius authentication on a wired switch port. And this is something that pretty much most switches can do. Like even the 8000 GS switches from Alitalysis can do, you know, MAC auth and 802.1x on a switch port. It's just that no one's doing it. And so when we secure the wired network, we're securing our, you know, physical ports. The other thing that we can do as well is by securing our physical ports is we can do dynamic VLAN assignment on our physical ports. So moving forward, if you get upgraded and you get part of the Secure Access Program, you will no longer need to do a manual VLAN config on any of your switches again. And basically, all of the VLANs on your switches will be there, but a device will automatically be placed into that VLAN based on potentially the MAC address of the device. And so when a device is plugged in, it's being pre-registered in the radius server. The switch recognizes the MAC address, does a radius auth, and then the radius server replies to the switch, and it comes back with a list of VLANs that this port should be allocated and configured with dynamically on the fly. And so that's what we're moving towards, is no manual VLAN configuration on switches anymore, which I think is pretty good. There will always be exceptions, but yeah, it's the general rule. Cool, so that's a little bit about security. Any questions on any of that stuff? Okay, so my next slide deck is based on the secure access and a product we have called Cloudpath. So first off, what I'll do is I'll introduce you to Ruckus Cloudpath. And so Ruckus Cloudpath is a product that we have which is available to anybody to purchase, which is effectively a radius server, but it's also an onboarding portal, and it does a bunch of other things as well. And so it's also a certificate authority, so you can store certificates inside of Ruckus Cloudpath, and it can issue certificates to your devices. It can send email and SMSs for guest authentication. It can interact with MDM solutions. And it is a radius server and a web server for onboarding. So it's like kind of like this suite of tools. Within the Cloudpath product, we effectively create an onboarding workflow. So this is a workflow that users go through in order to get connected to the network for the first time. And that workflow can be fully customized, and I'll show you what the N4L one looks like shortly. But it can be fully customized, and we can, for example, when a user connects, we could ask them to accept our user agreement. We could ask them if they're here as a visitor or an employee. If they're an employee, we could take them down a path that requires them to authenticate to our directory service, which might be AD or it might be something else. Then what we can do is we can determine if their device is corporate owned, and if it is, then we can issue a certificate to that device, and it can use that certificate to do EAP TLS now, anytime it comes onto the network. And so that's the idea behind Cloudpath. Okay, so now we'll get into the secure access thing. So secure access is the third phase as part of the Te Manito Hono project. So once again, this information is stuff that I've just learnt by working with N4L. This is not representing N4L. I'm just trying to give you guys an idea of how the thing works. And so we have this diagram that looks a bit like this. So sitting inside of the N4L data center, what we have is the Smart Zone controller, which we've spoken about already today. But they also have a Cloudpath cluster in there as well. And this is a redundant cluster. It's made up of North Island, South Island, and there are 6 nodes in the cluster. It's fully replicated across both islands. And then we have the equipment which is installed at the school. So all the schools have a 40-gate firewall. Then we've got the Ruckus access points, and then the switches. Now, the secure access program can only be completed on schools who have been through the hardware upgrade process. Because at the moment, all the processes that N4L have in place are designed around schools who have been upgraded. The basic idea is that from day one, once you have your new hardware installed, this concept of wired port authentication will start to kick in. So once you have your hardware installed, what they do is they go and deploy a standard set of VLANs down to your switches, including a management VLAN. So so we've got Cloudpath, which is the Radius server. We've got the network equipment on site. We've also got directory services. So a lot of schools now are using a cloud-based directory service. So maybe it's like Azure AD, or maybe it's G Suite, or maybe you've still got an on-site AD. So they're really the three primary types of directory that schools are using. Yeah, I don't know if anyone knows of any schools. I mean, potentially LDAPs as well. I mean, like you guys are used to doing your smart net thing.
All either Azure or
Yeah.
Office or Google.
Yeah, perfect. So let me know if you guys know of any other types of directories, but yeah. That's got an LDAP interface though, right? So it is possible. So Cloudpath can directly talk to any LDAP server, so that's no issue. So there's that, but there's also MDM solutions. So a lot of schools now have their devices enrolled in an MDM, so they can manage their devices, deploy applications, and all of that stuff. And here are the kind of some popular MDMs. You've got Intune, which is pretty popular. G Suite, or the, I don't know what they call the thing for managing Chromebooks. They've got the Chromebook console. Yep. And then you've also got things like Jamf, like Casper Suite, whatever it is, and then like Moisel's another one. Can anyone think of any other MDMs that's not here? Lightspeed. Yep. 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 So there's a few of them. So this is the solution overview, right? Let me go into a bit more detail. The reason that I bring up the directory services and the MDMs is because Cloudpath can interact with these services as well. And I'll explain to you in a moment why and how that happens. The other thing that we achieve as part of secure access is single sign-on for internet access. And so the basic idea here is that because I connect to the Wi-Fi using my own credentials, and I'm potentially using certificate authentication, the network knows who I am. And because of this, we have this system that allows the access point to send radius accounting packets to the firewall. The radius accounting data, which is transmitted from the AP to the firewall, tells the firewall my MAC address, my IP address, and the username, and a class of user, like whether I'm staff or students. And this information is sent directly from the APs to your local firewall. That allows the firewall then, using FortiGate RSSO, radius single sign-on, to then apply policy based on who the user is. And this all happens automatically. From the time I've authenticated through the Wi-Fi, then the firewall knows who I am, which is kind of cool. Did I overhear a conversation at lunchtime saying you guys are still using...
Linewise.
Yep. I believe that Linewise can support RSSO as well, or some radius accounting stuff. So if you're looking to do an integration with Linewise, that would also be an option. Yep. And so, yeah, so this is the architecture for single sign-on. This also, by the way, can work with 802.1x EAP TLS certificate authentication, but it can also work with dynamic pre-shared key. So if a device is unable to support certificates, you can put a pre-shared key on the device, and we can assign a username and a group to the pre-shared key, and then it can also participate in single sign-on. So there's two ways in which we could onboard a device to this system. The first is a manual onboarding. The manual onboarding process involves a user joining an open or a guest network and then getting a menu that looks something like this. So this menu is like, tell me who you are you staff or students, are you a guest? Then it will take them on a path to get onto the network. We'll talk about that shortly. The second thing is actually the most preferred. If you have devices which are managed, either in an MDM or part of Active Directory or something like that, then we can automatically push certificates to these devices using the MDM tools. So for example, most MDM solutions, such as Intune, allow you to do a thing called SCEP, which is the Simple Certificate Enrollment Protocol. We'll talk about that in a second. But through most MDM solutions, we can actually use them to automatically push a certificate to a device now. So once a device is enrolled in MDM, it'll automatically have a certificate installed on the device, which can be used for network authentication. And so this is the manual onboarding process, right? In this case, the user has identified themselves as an administrator, and it will prompt them for a password. Now we proceed to the next screen. So it's asking the administrator, are you trying to onboard a shared device, such as an Apple TV or a Chromecast? Is this a staff Wi-Fi device? Is it a wired device? Or is it a student Wi-Fi device? And so the administrator can select the device class, you give the device a name, and then it will give you a pre-shared key which you can use to connect this device to the network. And so basically what we're doing here by selecting the type of device is we're also determining the VLAN that that device will reside in. So for example, if we say it's a shared device, it will be placed in the shared devices VLAN. So this is an example of the onboarding, the manual onboarding process. For a non-administrator, it would potentially ask the user to then authenticate using G Suite or whatever, and then it would just take them through the process of automatically installing the certificate on their device. And so this is an example of what the N4L workflow process looks like. I think this has been a bit simplified, but there's potentially more options available now. But basically, you know, prompts you for credentials. Based on your group membership, it automatically determines if you're a staff or student, and it puts you down the correct path. And you know, for staff, it's like if it's a BYOD device, then there's options there. So one of the things that Cloudpath does is it's got a number of mechanisms for installing the certificate into the device. On an Apple iOS device, it uses a mobile profile thing, and it works quite seamlessly. It's able to quite seamlessly install a certificate and a network profile. On Android though, it's quite painful. And so on Android, we have the option of getting the user to go to the Android store and download the Cloudpath app. And once you've got the Cloudpath app, it will then contact the Cloudpath server and put the cert on your device. But that's way too painful for most users. And so what we do is we do an operating system detection. And we're using the web browser. We go, if this is an Android device, don't worry about a certificate, just give them a pre-shared key and put them down that route because it's much easier. But if it's a different type of device, then we'll give them a cert because it's much easier to install. Hopefully one day the Android story will get better. Yeah, so it's just an example of the workflow process. So the other thing that's been done as part of secure access is network segmentation, which involves basically just implementing a bunch of different VLANs and creating a bunch of firewall rules to say which VLANs should talk to each other. And there's a standard map of VLANs that I'll share with you in a moment. But the general premise here is that if you've got a shared devices network, that potentially both staff and students can communicate to the Apple TV or something like that in the classroom. You know, these rules would obviously be customizable on a per school basis because not every school wants to allow their students to transmit to Apple TVs, for example. So this is the kind of proposed VLAN map. And so at the top, you've got your device and service networks. So for example, like data loggers or like CCTV systems or VoIP phone systems, stuff like that. At the bottom, you've got your user networks. So you've got like students and then staff and then BYOD. Now, the students is interesting. So if you're a smallish school, then the recommendation is to have one VLAN for all of your students. But if you're a high school or someone a bit larger, the recommendation is to carve up your year levels into different VLANs. And the purpose of that is to cut down that layer 2 broadcast domain and also enable content filtering on a per year group level if required. And so that's the recommendation there.
If you're doing isolation, you don't need to worry about that because that VLAN's
Yeah.
stuff's all gone.
Yeah, agreed. The only reason left then is potentially if you wanted to do content filtering. But not all schools have LimeWires, right? So if you're just using the standard N4L 40 gate, yeah. Anyway, so that's the plan. So what they'll do, like when you do the hardware installation, is they'll drop these VLANs into your switch config on day one. Like when you get the new switches, they'll be in that you'll find these VLANs in there. You don't have to use them, but the VLANs will all be set up. Is the idea behind it. And then obviously you're free to add whatever other VLANs you want to your network. So it's your network. So Okay, so just real quick, I think we've covered this a little bit, but integration with MDM and directory services. So yeah, as I say, the purpose of the MDM is to put certificates on devices, and the purpose of integrating into directory services is obviously to authenticate users against your existing directory. When we talk about directory services, so this is the general thinking. The preference where possible is to use LDAP. And the reason for this is, to be honest, like LDAP is actually a directory protocol. SAML is not a directory protocol, it's an authentication mechanism. A lot of people these days are really big on SAML and are really big on potentially OAuth, but these are just like web-based authentication protocols. They're not full directory services. It's really hard to get good group membership information through a SAML request, for example. An LDAP request is designed to give group information and all of this stuff. And so the preference is to use LDAP where possible. But the problem is we've got so many schools around the country now using like G Suite and Azure AD and things like that. And so officially G Suite supports LDAP, but it doesn't support LDAP on the free license that all the schools are using at that license tier. You've got to buy G Suite Enterprise Edition in order to get LDAP access. And so the preference for G Suite is... I don't think...
Even more than that.
Yeah, it's got to be more than that.
Okay.
It's got to be Enterprise, I think. Is that what they call it?
I think so.
Yeah. And so that means that for G Suite, we're stuck using SAML.
The good news is that SAML on G Suite now supports OUs.
Oh, nice.
Yep.
Interesting.
So I don't think Intralo actually implemented it yet.
Right. Well, let me show you the next screen. This is probably really hard to read, but here's an example of, on the left-hand side, how they set up Cloudpath with SAML. And so what they're doing is they're matching the department field today, because it's the only way. We can't actually pull group information using SAML. And so we're looking at the department field and going, well, whatever the value is of the department field, that can help us determine if they're staff or students or their year level. So the requirement would be to populate the department field moving forward for that. But for Azure AD, it's a bit better because we support groups inside of Azure. And so the only thing here is we're using the group GUID as opposed to the group name. And so it doesn't make it friendly to read the policy, but yeah. And so it works though. I mean, you just have to use the GUID.
And you can have multiple groups.
Yeah, exactly. Exactly.
And on SAML, you can have multiple, you can have staff, support staff, caretakers.
Yeah.
Whatever you like, they just build it into the workflow.
Yep, exactly. Yeah, good stuff. So that's how we do the group matching using the SAML. Look, with LDAP, it's so easy, it's not funny. LDAP, we just do actual groups, and we can type the group names that you want to match to take them down a workflow, and it's very easy. And the final thing I have here is the SCEP, right? So SCEP is the protocol which we use to interact with the MDMs and Cloudpath in order to actually produce the certificate, which will go onto the device. And so, as I say, simple certificate enrollment protocol. And here's an example using Jamf. And what they do here is the MDM server is a SCEP proxy. So the MDM server actually does a SCEP request to Cloudpath, pulls the certificate and pushes it down to the device, as opposed to something like Intune, which would then actually get the device to send the SCEP request direct to Cloudpath to pull a certificate. Now there's a bit of security around SCEP. You have to provide like a unique security key in order to subscribe to a specific template of certificate. So yeah, that's all baked in there. But what you do is you put the security key into your MDM and the URL for Cloudpath, and then devices will automatically get certificates from Cloudpath for Wi-Fi authentication. Cool. There's a lot of stuff there. It's like a lot to take in, and it will be slightly different for every school. It's not this like hard and fast thing. Like for the smaller schools, yeah, they try and cookie cutter it and make it kind of the same for everyone, and that reduces operational overhead and stuff like that. But for the larger schools, there's no way they can try and force this on everyone. There's going to have to be flexibility, and there's been a couple of large schools done with secure access so far, just 2 actually. Yeah, it's quite different, large schools versus small schools. Small schools, I think, is relatively easy putting them through a process like this. but
The certificate enrollment we find is only for one-to-one devices.
yes.
So really only for Tele laptops
Mm-hmm.
and for BYOD devices. Everything else in primary schools is shared devices.
Yep.
Many users using the same device.
Yeah. And so I think the general concept behind that, so the concept is we're trying to get away from this shared device thing, right? But we can't in reality. But the concept, I think, is that if you've got a fleet of iPads, like a cow full of iPads or something in a room or in a classroom block, I mean, there must be a member on staff that has ownership over that equipment, right? There must be, like, if I've got like 5 iPads in a junior school classroom or something, theoretically it's the responsibility of the teacher in that room to look after that equipment, right? And make sure the kids are using it. So theoretically, what we should do is issue a single pre-shared key to that teacher's room and all their devices.
Junior iPads.
So this is, and that means that whenever those devices get on the Wi-Fi, they're identified as a junior iPad user, and then that goes through to the firewall, and they get content filtering that's associated with that as well. And so, while we want to do as little shared devices as possible, it's inevitable there's going to be shared devices. When we do shared devices, we want to make sure we try and at least nail it down to like a staff member or a department or someone who has ownership over the use of those devices.
The good news with Chromebooks now is they're using the Cloudpath extension.
Yep,
So
nice.
it's automatically pushing out the certificate on a per user basis.
Yeah, that's really good, right?
That's very cool.
Yeah, the Chromebooks, you don't have to do anything. So long as your Chromebook's enrolled, then it will automatically get a cert and everything just works.
Yeah. And part of the infra rules is that all Chromebooks should be enrolled
Yep.
before this project starts.